Hi, today we are going to see how to use the CAMP tool to amplify configuration test. So CAMP is an open source tool that we have developed in the STAMP project, a European research project. So let's see. So what is configuration testing? Let me assume that we have a simple service. Here in that case it's a greeting service that simply returns a welcome message given your name. And so, of course, this service is not running in a vacuum, so you have to deploy it on a servlet container. So, for instance, a possible software stack to run this greeting service would be to run it on a Tomcat server running on top of a Java runtime environment into a Linux container. So, of course, we have integration tests that come with it. So, for instance, we would have another program running in another container. That would be our integration test, and this other program would basically request the greeting services and check that it gets an HTTP 200 code as a response. So that would be our integration test. That's very classical. And what's configuration testing in this setting? It's that we want to be able to test that our service is operational given many different software stacks. For instance, we could be running on very many different versions of Tomcat. Could be Tomcat 7, Tomcat 8, Tomcat 9. We could be running on very different many versions of the Java runtime environment. We could also be using different vendors. We could be running on top of Jetty, on top of Glassfish. We could also be using different configuration for instance, the Java runtime, changing the garbage collection options, for instance. I mean, there are many different settings we could use to change the environment of our greeting service. And the idea of configuration testing is to try to test as many as possible of those settings. So to do that, we've developed the CAMP tool. And the CAMP tool takes two parameters. So the first parameter is a test template. So that's basically your application, your system under test broken down into components, as we have seen before in the greeting service. That the greeting service, the test component, the Tomcat server, the Java runtime environment, for instance. So they're the components. And then we have a variation models that specifies how we can combine those components to build different configuration, but also what we can change and how we can change things in this template. So once we have those two inputs, what we can get with CAMP a report that tells us which tests have passed and which tests have failed in what configuration. So to do that, CAMP uses two things. The first thing that CAMP uses is a constraint solver to compute all the possible configuration that can be built from the variation model. And then it uses the container engine, in that case it's the Docker platform, to deploy every single configuration in isolation and ensure that tests are not interfering one another. So the CAMP process is fairly straightforward. So the first step is to generate the alternative configuration from the variation models. But what we get from that is only a blueprint of each configuration. So then we have to realize those configurations, that is transforming this blueprint into something that can actually be deployed. And eventually we can trigger the test on all configuration and collect the result and get some feedback about what change in the environment break the system. So let's go and try it. A few links if you want to follow along. So the CAMP is an open source application available on GitHub, and the documentation is online. And if you try it, and if you have some troubles, feel free to reach out on the mailing list. We'll be happy to help. All right, so let's see how to use the CAMP to amplify configuration test. So the first thing I want to do is to install CAMP. So CAMP is available as a Docker image, so I'm going to just pull the Docker image from Docker Hub. So let's see if I type, so it's clear at my machine, so I'm just pulling the image, which is under my name and the latest version. Alright, so while I'm doing this, I'm just gonna open another terminal here, and I want to show you a bit the layout of my directory. So if I look at what I have here, so I'm not in the right directory. If I look at what I have here, so I have two things. I have a camp.yaml file that is a variation model that tells us what we can change in your application. And I have a template directory that contains my application. So we can look at the template directory. So for instance, if I look so we can see that I have first a Docker compose file that describes the service orchestration. So in that case, it's fairly simple. It's just the test container and the greeting service in another container. And then the thing that's particular for Camp is that for my greeting services, so there is a software stack on top of which my service is running. So this software stack includes Tomcat running on top of a Java runtime environment, and on top of this Tomcat, we've put the greeting service as a WAR file. So the thing is that in that software stack, every single component has been isolated in its own Docker file. So I have a subdirectory for the greeting services and a Docker file to build this. I have the Tomcat a component and its own Docker file that installs Tomcat, and I have the Java runtime environment and its own Docker file. And we haven't done that for the test component, which run on its own container. So here the software stack is kind of flattened into one single Docker file. But it's by doing this that Camp can basically reshuffle the software stack and make change into the software stack. So here, for instance, we want to have several deployments of that greeting application using different versions of Tomcat, and we can do this because we have isolated Tomcat in his own component. So let's look, for instance, at this this Tomcat Docker file. So let me open. So I'm going in the template directory, Tomcat, and the Docker file. So here you see the Docker file, and we have been working a bit on this Docker file in order for the version of Tomcat to be indicated into variables. So for instance, the major version number is indicated in the variable Tomcat major, and the revision number is indicated into another versions. And basically what we do is we just pull from internet, from the apache.org archives, the tarball that contain the version of Tomcat we want. We decompress it, and then install it where we feel it's convenient. That's what we do in that Docker file. The thing that's important to note is this from statement at the beginning, from camp/runtime. This actually, it's a marker that Camps uses to know what from statement he can override, because he's going to decide how we stack the component one on top of the other, and so he's going to override those from statement. So this is basically the architecture of our template directory. Let's have a quick look at that variation model now. So for instance, if I open the camp.yaml file, so what do we see here? So the first entry is the goal, and we are saying that the goal is to have a configuration where we run the integration test. So integration test in this context refers to a service. So we see below we have a list of components, and the first component is named tests, and we see it provides this integration test service. So there is lots of things. I'm not going to go into the very detail, but what I want to say here is that all the components you've seen in the template are actually described here. So the greeting services, the Tomcat component, and the Java runtime environment, GRE. So, and what is important is that each component provides and requires services and features. So services are the capabilities that are available from one container to another, so remotely somehow, while the features are the capabilities that are only available within one container. So for instance, greetings or greeting services, it provides a services named greetings, and this services is going to be used by the test component. If we see that the test component actually requires these greeting services, and by contrast, the greetings component requires a feature, not a service, in that case, a features servlet container. So a feature is something, again, which is available only in one container. And of course, the Tomcat component is going to provide that feature. So if we were to have a very complicated service orchestration with many components, we can see that we can have variation because we can have multiple components that provide the same service, and we can also have multiple components that provide the same feature. And in that case, CAMP will pick and try to build all the possible configuration that it can make with the component and their service and feature provision and requirements. The last thing I want to say is that in this Tomcat component, we have defined a variable named version. And this variable can take three values, namely v7, v8, or v9. And for that variable, we define actually what to do on the template depending on what value CAMP puts in there. So, for instance, we can see that the realization has two entries, so there are two substitutions on the Tomcat/Docker file, and basically we substitute the pattern Tomcat underscore major equals 7 by other values, depending. So, for instance, if the value v7 is selected, then we replace by the same thing, but if it's v8, we replace by Tomcat major equals 8 or Tomcat major equal 9 if the v9 value is activated. And we will proceed in a similar manner for another text fragment, which is a revision number, so Tomcat revisions, and we replace it by some proper revision numbers. So when we are done with this, we have made those two files and prepared the template, and then we can use CAMP basically to generate all the configuration and execute the test in all configurations. So let's see how this works. So CAMP, we have downloaded CAMP as a Docker image. So now if we look at what image we have CAMP available. So we are going to just start a bash session into this a container with CAMP. So this is going to be an interactive session, and we have to mount some volumes. So the first things I'm going to mount is my local directory, which I want to mount in /greetings. And the other things I want to mount is actually the Docker socket. Yes, docker.sock, and I want to mount it at the very same place. Docker.sock. So what this does is that it will allow our container that contains CAMP to create sibling containers. And it's in those containers that CAMP will deploy the configuration it generates. So that's important. And then, so what image we want to run, fshovel/camp latest, and we want to run bash. I think this is correct. Let's try. All right, so we have arrived here. So now if we we can try CAMP, see if CAMP is running. So if I run the version number, so we see that we're running version 0.9, which is the latest version, and things that matters are, we see that on this CAMP image we have already installed the v3 constraint solver and Docker version 19. So that's what we need, the two dependencies of CAMP. So now we can go and we can ask, oh sorry, I'm not in the right directory, so I'm moving into my greetings directory. What do we have here? We have the file we've just discussed before. So now I can ask CAMP to generate all the configuration in this in this directory. So the -d option is to specify where are the template and the variation model. In that case, I'm already in that directory. And we want all the configurations. So we see he has found 1 configuration, 2 configuration, and then 3 configuration. So now I'm just changing terminal, coming back to the host session. Root. Yes. So here I am on my host in the same directory since the directory was mounted. We can see that Camp has created an out directory, and we can use a visualize script to get a view of what has been generated. So let me look at what was generated. So it's in document. Samples, Java, that's where we are, and then we have got an image that was generated. So we see basically that, this is a simple example, but so Camp has found 3 configurations. The first one is using Tomcat version 7, the second one is using Tomcat version 8, and the third one is using Tomcat version 9. But at that point in time, Camp has only generated blueprints for those configurations. So for instance, if we look at what's in this, what is in this out directory. So you see, for each configuration, he has only generated a YAML file that quickly describes what component and what value he has put in variables. There's nothing else. So the next step in the Camp process is basically to ask Camp to copy and modify the templates according to the realization rules we've put in the variation model. So to do that, we have to invoke Camp realize in this way. So there's no specific options needed here. So we see that Camp has built all configurations. So now if we do the same, and we see that many more things have been generated. For each configuration, we can see that now there are some scripts that are generated, and the templates have been copied and modified for each configuration. So I just want to show you quickly, for instance, the type of modification that Camp has made. So let's open, for instance, the first configuration, so config 1. And we want to go in the image directory, and then let's say look at that Tomcat. Let's try config 2, images, and Tomcat 0 Docker file. So what do we see? We see that the versions have been changed, that now this version 2 is gonna use Tomcat version 8.5.47. That's what we wanted to see. But another thing interesting is that this from statement, which used to be cam/runtime, has been overridden by something else, which is cams-gre_0, which is another image that will be built when this will be deployed. So now we're ready basically to run all our configurations. So it takes quite some time. But Camp has an option to see how the run will looks like. So to run the configuration, the command is camp execute, and in this first run I want to simulate it. So I just want to have some sort of a dry run where I want to see what shell command are going to be invoked by Camp to see what's going to happen. So same, I'm giving the directory, and I want to basically, let's say, run only one configuration 2, for instance. So I'll just expand the options. This is include only the configuration 2. So you see, so this goes fast because nothing has been actually executed, but it's basically showing us what Camp would have done. So we see that Camp would have first triggered the build image script to build up all the images that he needs. Then he would have deployed the configuration using Docker Compose, and then connect into the container that contains the test, and then trigger the test command, which is in that case Maven. and then it would have copied the test reports out of the container, and eventually it would have fetched the logs of what happened during this service, this run, and eventually stopped the service orchestration. And then it would have output summary. So now we can try the same, basically removing the simulation flag, and we can see what happened. So this takes a bit of time. We have to wait a bit. I think this really depends how big is the application you want to test. Sorry. So it might take dozens of minutes if it's really a big application. It really depends on the complexity of the application, the size of the Docker images that we are pulling when we are deploying this application, and also how many tests you're running and how long it takes to run those tests. In this simple example, so what takes quite some time is basically to build all the images, so to go through all the components. So basically first we build an image with the Java runtime environment, and then on top of this we build another image where we deploy Tomcat, and eventually on top of that new image we build eventually the final image where we put the greetings service. So this takes some time. So now we can see that Camp has basically finished to build the images and is basically starting deploying the service orchestration, and then right away starting to trigger the test. So in that case there is only one single unit test, that then the single request the greeting service, and eventually check that it gets an HTTP 200 status code as a response. Alright, so things have completed, and you see that in the summary we see that one test has been run on one configuration, but this is because we have asked Camp to test only one configuration, the configuration number 2. We could have asked 1, 2, 3, all the configuration if we wanted to. So that's how Camps works. Really feel free to give it a try if you have an application, and reach out to us if you are struggling. We are there to help, and we would be very happy to do so. Thank you very much. Bye bye.